Hi everyone, my name is Juan Pablo. Welcome back to a new YouTube video. In this time we will talk about segment routing. Okay, we have been quite absent for some time, but now we came back with all the energies and with this interesting topic because it's quite popular and used in many providers. Together with SR-V6 recently as well, so it's quite been adopted often. And we will explain what are the components behind segment routing. We will explain where and how it fits into the IGP protocol, how we can configure into a network, what are the commands that we can use for enabling the control plane, the forwarding plane, how we can verify that the labels are being exchanged. And at the end, we will test it out the traffic between customers in this lab environment, right? As you can see here, I have a small network which is composed by P1, provider 2, P2, and the raw reflector on the top. And we have C1 and C2. And here we have a BRF that is basically isolating the users, C1 and C2. And over the network here, we have ISIS in the area 1, okay? And we have MPLS LDP configured. And over here we have a raw reflector, which we have a VPN before session over to the PEs, and we exchange the routes from the customers received on the PE to the raw reflector and then propagate it to each other. Okay, we have MPLS LDP, so the idea is that we will configure segment routing, replacing LDP with segment routing configuration, and basically show you what are the commands again to enable it. Okay. Now, before we talk about segment routing, it's important to talk about LDP and what are the facts that makes LDP less attractive and makes segment routing more attractive, right? So, but before going into that, it's important to mention that segment routing fits into the concept of MPLS, right? You know, MPLS is multi-protocol label switching. It's basically what many providers and in the world of service provider we use for a labeling. Forwarding, okay? The forwarding based on labels. Normal network infrastructure use IP, right? In the case of SR-V6, it's used as well IPv6. But whenever we are talking about MPLS concept, we use or we associate with the concept of labeling. And actually LDP, both LDP and segment routing fits into this concept. That's why in many books we see MPLS LDP, and also we see segment routing MPLS, right? And it's quite common again because both of them use the concept of labeling. Segment routing doesn't remove labeling at all. It just implements new concept of assigning labeling into the network, okay? Now, again, before we dive into segment routing, we will explain what are the possible disadvantages that LDP has that makes more attractive to use segment routing for providers, okay? And I will start with increased complexity and manageability, okay? From the design perspective. Why? Because LDP, as you know, it works, if we, for example, have this network infrastructure, P1 and P2, we need to enable LDP over the interface, right? It's a protocol. It's additional protocol that has to enable over the interface. And that protocol, of course, exchange hello packets and establish an adjacency over the TCP and UDP port 646. When we add a new protocol over the network, it means that there is another potential point of failure, another potential thing to manage or to take care of. And this already increased the complexity and the manageability, okay? So this is one point why LDP is not that much attractive compared to segment routing. Segment routing instead, for example, is attached or is carried into the TLBs or LSAs of the IGPs. In this case, OSPF or ISIS, okay? In the case of ISIS, for example, all the concept of segment routing labelings that are prefix seed and adjacency that we will talk about in a little bit more are carried into TLBs, the timeline values that are quite common in ISIS for supporting new features, right? The timeline values are, if I'm not mistaken, 237, 236, 230, 5, 135, I think, for level 1 and level 2, and then we have 238 as well, right? This one I think is for prefix seed, this is for adjacency seed, this is for the support of segment routing, and this one is for transmitting prefixes plus label in segment routing. If I'm not mistaken, that's the correct order. Okay, so that's another difference, big difference between segment routing and LDP. Again, in LDP we need to enable LDP over the interface, and it's another protocol, hello packets. The router needs to process the hello packets in the CPU, and it already became more complex and of course increase the manageability. In segment routing, there is no protocol, additional protocol over the network. Everything is encrusted or carried out over the IGP. So we reduce the complexity there and less things to manage, and we do it simple. That's why if we compare SRv6 as well, right, with segment routing, SRv6 doesn't use the concept of labeling. SRv6 do the forwarding based on IPv6. So we already reduce another complexity for not using labeling and only using IPv6. Okay, so this trend is quite common in service provider because we are trying to reduce the complexity and increase efficiency. That's the goal with the evolving technologies. Okay. Another thing that I would add into segment routing, into LDP, that makes segment routing attractive is the also complex and even limited traffic engineering concept, right? So if we remember in LDP and how many of us have been dealing with configuring traffic engineering tunnels in all the P routers, you need to create a long templates, you need to verify, you need to, there is per each tunnel around 5-6 lines as minimum that you need to configure. If you have more things detailed into the tunnels that you want to go for that specific service, for example, then you need to add more things over there, which already became quite complex to manage, quite complex to implement. The changes over the maintenance windows are larger, and if you have many tunnels to configure plus backup, then it increases, of course, more. So that's another, let's say, facts that makes segment routing more attractive than LDP. And another important thing is that it's quite complex for LDP traffic engineering, to using MPLS traffic engineering tunnels in LDP, to create a specific policy per service. Okay, meaning that, for example, if you have in this router, let's take an example, P1, you have a VRF green and you have a VRF red. In MPLS traffic engineering, if you want to create a different path for green over the top and red to follow over down, and associate that tunnel of MPLS traffic engineering for that particular VRF and for that particular service, there is it's not that easy to do, right? It's not that easy to attach the tunnel over the specific VRF as it is in segment routing, okay? Sometimes even some solutions are to configure different loopback interface in the other end of the other PE. So associate loopback 0 and loopback 1, for example. Loopback 0 for prefixes that are being advertised for VRF green, and another loopback 1 for prefixes that are being advertised for the VRF red. And then you create tunnel 0 over here and tunnel 1 over here. This one with destination to the loopback 0 and this one with destination to the loopback 1. And then you can create separate channels for the different next hops for those particular services. In segment routing, that complexity is reduced completely by the use of manual policies, by the use of ODN, the PCE, and actually, if you recap into the videos that I have, you will see that there are many of them how you can configure all of those things. Okay. So then we have that LDP increase the complexity and manageability. It's hard to do traffic engineering tunnel as well. And the other thing that I will say as well is limited probably with the next generation concept that includes automation, right? Why? Because in segment routing, we can integrate this with many other automation tools like Crosswork, for example, NSO, and any other solutions that are next generation automation solutions. And we can be more efficient, right? And the visibility and monitoring of those traffic engineering policies in segment routing are much more easier and to do and to manage, okay? With LDP, we have little limitation on that sense, okay? So those are the difference between LDP and segment routing. And another important fact that I would like to clarify is that segment routing is also being classified as a source based paradigm, right? What does it mean, this source based paradigm? It means that the traffic decision is made in the source of the packet life, right? So for example, if I have a traffic flow between P1 to P2, with this source-based paradigm means that P1 decides where the packet and traffic will go to reach P2. It will go over the top or it will go down over P2, right? So we can decide where the traffic will go. Now, this source-based paradigm is true whenever we use SRT, because we can decide as well with SRT where we wanna the traffic to go, okay? So that's true in whenever we are using SRT. Whenever we are not using SRT, segment routing does the traffic forwarding based on the IGP cost, the lower IGP cost that follows between P1 and P2, same as LDP does, okay? So this source-based routing paradigm is whenever we are using SRT, okay? Perfect. So let's go now into the components of segment routing. Okay, segment routing use, as we mentioned, and if we focus specifically into ISIS, it uses the TLBs that we described before, and it's encrusted into the routing protocol. Okay, it's not a separate protocol that we configure over the network. Segment routing has two labels: prefix seed and adjacency set. Okay. The prefix seed is a label that we configure under the loopback interface. So we go over loopback interface, router ISIS, interface loopback 0, and we assign a label, okay? That label is between the range of 16,000 and 23,999 in iOS XR, okay? So we have this range of labels that are specifically meant to be used for segment routing. In the case of LDP and also BGP LU, for example, they use a label of 22,000 plus. So the range of the labels start in 24,000. Sorry, 24,000, not 22,000. Start in 24,000, okay? So the devices use this range to assign a label to any prefix in the network. In the case of segment routing, the range is this one, 16 to 23,999 in iOS XR, and this is considered the segment routing global block. Global block. Okay, so this is a range that we tell segment routing to use the labels, and if we want to configure the prefix seed use the segment routing global block that is configured into the device and assign labels to the loopback 0. Okay, so that label we can assign, we have to assign manually, right? And there are two ways that we can assign the prefix seed. Okay, one is absolute, is an option that we will see in the CLI, absolute, and the other is index. The absolute is basically an static label. So we configure the label statically. So for example, I go to P1 under the loopback 0 and I configure prefix seed absolute 17,001, for example. Exactly that value, okay? In the case of index, I decide or I assign an index, right? A number. It can be 100, for example, 100. So the router calculates the label for that prefix in the loopback using the segment routing global block plus the index configured in the loopback. So if the index, if the segment routing global block is 16,000 plus 100, then the label will be 16,100 to identify this loopback 0. Okay, so we have these two options to configure a label under the loopback 0 now, and the prefix it. Now you will wonder, why a prefix it? Why it's not like LDP? LDP assign labels to all the prefix in the RIP and FIP, right? So as we recapped before, when we have the adjacency of LDP, LDP goes over the RIP and FIP and assign a label to every prefix and forward to the neighbor all the labels that each of them have been assigned. So they made them aware about which label they have been assigned. They don't assign specific labels for specific prefixes, right? Even if the range of prefixes are point-to-point, for example, LDP assigned to all of those point-to-points, loopbacks, etc. Okay. In the case of segment routing, why we have prefix it? Well, prefix it again is meant to be to the loopback 0 because the most important prefix into a service provider network is a loopback 0. Not really the loopback 0, but the loopback being used for the BGP control plane adjacency with the route reflector. Why? Because that loopback is being used as a next hop whenever the router advertises prefixes to the other device. So for example, in this case, P2 has a loopback 0, 2, 2, 2, 2. P1 has 1, 1, 1, 1. So whenever P2 receives prefixes from the customer, for example, C2, P2 receives those prefixes over the VRF. Those prefixes are being forwarded into BGP BP and B4, okay? And they are sent to the route reflector. Whenever P2 forwards those prefixes to the route reflector, the next hop for those prefixes is the loopback 0 of P2, right? So those BGP updates are being forwarded with the next hop of P2. And whenever P1 receives those prefixes from the route reflector, P1 see that those prefixes, customer prefixes, are reachable by the loopback of P2. Okay, that's why, and again, in the concept of LPLS and all label forwarding, the traffic between one side to another has to be end-to-end LSP, label switch path. The label should be end-to-end, okay? So segment routing, in order to make sure that we have a label for the important prefix in the network, we need to configure prefix it under each loopback interface of the PE devices, okay? And in that case, we assign labels to the most important, again, most important prefix in the network, okay? We don't assign labels to all the prefix like LDP. LDP doesn't do this differentiation, okay? And the other label that we have in segment routing is adjacency seed. The adjacency seed is the label that each device assigned to the point-to-point interface between them. And they exchange that label as well over ISIS, okay? And that label allows also to create some segment routing traffic engineering paths if we wanna tell for one traffic to go over this router or the other router. We can specify the prefix seed, we can specify the adjacency seed. Both of them we can specify for create our traffic engineering tunnels or even IP as well, right? Even if you look into the other videos that I have in the channel, there are some of them that we can use labels for defining the path, okay? So those are the most important prefixes in segment routing. Sorry, labels in segment routing. Prefix seed, we saw, is important because reflect the loopback 0 of each PE, and then we have the adjacency seed that reflects the point-to-point of every link, and we can use for creating our traffic engineering tunnel, okay? And the advantage of this is that all of this is encrusted into or carry out into the IGP. We don't need another routing protocol or another protocol to implement in the network. Everything is going on the IGP protocol, okay? So this is more manageable We don't need to troubleshoot another protocol. It's less complex. We don't need to take care of hello packets. That QoS is not, for example, allowing control plane packets for LDP, or is being dropped in the queue. We don't need to care about those things if we go into more deeper layers. Okay. Now, segment routing also has advantage in the traffic engineering, right? As we see in the previous videos, with segment routing we can do SRT tunnels per service, per VRF quite easily. We can decide the traffic to go over the path on the top or over the path on the bottom based on different patterns. For example, latency. There is T metric as well, and at the end the IGP metric. And latency probably is the most attractive because we can decide, for example, that the traffic between C1 and C2 from the perspective of the P1 goes over the less congested, or let's say less, the path that has the less latency over the network, right? And with latency, there is another protocol called perform measurements that does the calculation and export to the ISIS. We will not talk a bit into this, but you need to know that that's an advantage of segment routing, okay? That you can create your policies per service, per VRF. You can go segment routing use the concept of coloring, right? That we explained in another YouTube video as well. And in using the concept of coloring, you can steer the traffic engineering policy for that specific VRF, okay? So it's easier comparing to the complexity that we have in MPLS traffic engineering. And then we have the latency, that of course latency allow us to provide to customers a proper service and better service, and is more profitable as well for many providers, right? So those are the advantage of SRTE compared to segment routing, sorry, compared to LDP traffic engineering. And the other is that SR also brings and is meant to be a next generation protocol, which opens many doors of automation together with all the solutions that has been out, like Crosswork, for example, or NSO, right, are quite easy to integrate with segment routing, with the PCE as well, and it opens the door to the automation part. Okay, good. So these are the concept of an advantage between segment routing and LDP. This is the part 1. I will upload the part 2 with the lab, so we will stop here the video because it's quite long. So thank you very much for watching, and see you in the next part.